Hello everyone. So previously we had discussed the meat in the middle algorithm, right? So we have come to the end of this one algorithms playlist or this one even advanced algorithms or this one miscellaneous this one playlist or the entire algorithms playlist. So this is going to be the last algorithm that we'll be discussing. Yeah. So after discussing after the discussion of this particular algorithm, we'll be left with only solving the system design problems. Yep. So we are solving that one parallelly actually, but we'll be left with only solving the this one. What do we call? Mm, how do I say that? Solve this one. Yeah. After discussion, we'll be solving only system design problems actually. We will be done with the this one. Basically, yep. This is going to be the last one, and we'll be done with this particular this one algorithm playlist, all the algorithms playlist actually. And this is going to be the last algorithm, as I've said. And yes, this is going to be the special one. Anyways, so let's move on with the this one definition part first. Let's see what the subset enumeration algorithm definition states here, right? Subset enumeration algorithm is a fundamental combinatorial or this one technique. It is used to generate all the possible subsets of a given set, right? It is used to generate what? All the possible subsets of a given set or the list. It helps explore every combination of elements. Again, it helps explore every combination of elements essential in brute force backtracking and power set problems. Brute force backtracking and power set problems, right? Let's move on with the explanation part here. First thing, if a set contains n elements, it has exactly 2 to the power of n subsets. Again, if a set contains n elements, it has exactly 2 to the power of n subsets, including the empty set and the set itself. Including the empty set and the set itself. We can generate these subsets using two main approaches. Yeah, we can generate these subsets using two main approaches. One is bit masking approach, which represents the inclusion or exclusion of each element as bits, either 0 or 1, right? So we will be going with a bit masking, I believe. Yeah, let's go with a bit masking itself. Or we can just go with a recursive backtracking approach. It includes or exclude each element recursively, right? So below we'll be making use of the bit masking as it's efficient and easy to validate computationally. Yep. So let's go with a bit masking approach. Right, let's go with a bit masking approach. First thing, let's start writing the algorithm. Yep. So first let's write the function to generate all the functions using bit masking. I'll just go with here the function generate subsets, right? I'll just go with generate subsets, right? I'll just pass the array over here. So within the generate subsets algo, so let's get the number of elements in the array. So I'll just go with n equals length of the array. Sorry, I'll just go with length of the array, right? So this is fine. The first thing, after getting the number of elements in the array, we have to compute or we have to calculate total number of subsets that is equivalent to the 2 to the power of n. Right, so I'll just go with here, or let me do one thing. N, sorry, go with total subsets here. Yep, equals 1 left shift n. Yep, so this is fine. The next step would be we have to initialize the result list just to store all the subsets. So I'll just go with a variable name result itself. Let me initialize this one to the empty list. Next, we have to loop through all the possible bit masks. So this one will be for mask in range. What will be the range actually? Up to total subsets, right? I'll just go with a, let me pass the total subsets here. So this is fine. Let's go with the temporary list for current subset, right? I'll just go with subset here. Yep. So this is fine. The next one, let's do one thing for each bit in the bit mask. So let me go with a for loop for each bit in the bit mask. I'll just go with for I in range, and so within this for loop, let's check if ith bit is set, means include array of I actually. Let me go with a for loop here. If mask bitwise and here this one left shift I. So this is fine. So within the if condition, I'll just go with the subset dot append. What we need to append actually, we have to append array of I or iterated value of the array. So this is fine. Next, what we will do within the for loop or outside the for loop, we have to consider this one, right? So finally, we have to add the subset to the result, right? I'll just go with the result dot append. So we have to append the subset to the result actually. Let me pass the subset here, right? So we are left with only one step, nothing but we have to return all the subsets, right? So we have to return all the subsets. Just give me a second here. Let me do one thing. Let me return the result actually. Yep. So this is it for the algorithm, right? So next, let's go with the example usage of the input. So I'll just consider the simple one. I'll just go with 1, 2, as well as the three elements. Yep. So we have to generate all the subsets, right? For this 1, 2, and the array consisting of the elements 1, 2, 3. So I'll just go with subsets here. Let me call the function generate subsets, the main function here, this one. Yeah, generate subsets, and let me pass the array here. Yep. So finally, what we will do, let's print each subset. So I'll just go with for sn this one subsets actually. Yep. So within the for loop, so let me print. I'll just call s here, right? So this is fine. Yeah. So what is the output that we need to get? So we have already discussed the algorithm. Let me first explain whatever we have written actually. Let me explain the algorithm so that we don't forget, right? So generate subsets. So this is the function, right? So n equals length of the array. So this basically what we are doing, we are finding the number of elements in the array. Total subsets, this one, line number 21. So we are making use of the bit shift just to compute 2 to the power of n, right? So then we are just going with a for loop here. So here, this one, we are iterating through all the bit patterns from 0 to 2 to the power of n minus 1, right? So again, we are going with one more for loop here, nothing but the inner loop. So this one basically checks each bit position in the current bit mask. Then we are going with a simple if condition here, line number 29. So if the ith bit is set, then we have to include array of I in the subset. That's what we have done. Then what we are doing, we are adding the formed subset to the list of all the subsets, and then we are finally printing every subset one by one. Yep. So this is fine. Yeah, then let's move on with the output part here. What is the output that we need to get here? First thing, the subset, all the subsets, we are generating all the subsets. First thing, we have to get the empty subset. Empty subset is always the subset of the given elements or given array actually, right? So this is one thing. So this is one subset, one, and this is two individual elements we have to consider. So these are uh, the subsets actually. Next, one more thing, we have to go with 1 comma 2, so this is also one subset, and we have to go with 1 comma 3, so this is also one subset, and finally 2 comma 3, 1 comma 2, 1 comma 3, 2 comma 3, this is also one subset, and finally all the elements grouped together 1 2 3. So these are uh, all the subsets for this one, right? 1 2 3 for the array 1 2 3 that consisting of the elements 1 2 3, 1 2 3 4 5 6 7 8 subsets that we need to get here, right? So let me delete this one. Basically, yeah, this is the output that we need to get here, right? So each subset corresponds to the binary bit mask, right? So within the algorithm, right? So this is fine. Suppose, for example, if you consider 101, it includes the element at index 0 and 2, right? So that will be 1 comma 3. Yeah, that's the simple example. You can just ignore this one. For now, let me run actually. We have discussed the algorithm completely along with the example part, right? Also the output part. We have to get the desired output. Let's check the same actually. Yep. So let me give control. Sorry, what did I give here? So control J. Mm, Give clear screen. Let me give Python followed by the file name.py. Yeah. So see here, empty subset 1, 2, 3, then 1, 2, 1, 3, 2, 3, and finally 1, 2, 3, 8. You can count 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets are generated, all the subsets, right? So we have got the desired output. We have got the desired output. So whatever the code that we have written or algorithm that we have written works absolutely correct here. Works absolutely correct. Yep. So this is fine, I believe. Next, what we will do here, as we are completely done with the algorithm part, um, let's do one thing. Let me summarize whatever we have learned so far, right? So we have some 3 to 4 points that we have to remember this one at any cost. So let's discuss the same. I just wanted to discuss the same with you guys. Yeah. So first thing, subset enumeration algorithm, what it does, it explores all the combination of set elements, right? It explores all the combinations actually. Yep, of a set element. So this is the first point. You have to keep this in mind. Subset enumeration explores all the combinations of a set elements, right? So next, what does it use actually? Subset enumeration algorithm, it uses bit masking, or you can go with a recursive bit, this one, backtracking as well. So bit masking is fast, and then let's go with that itself, right? It uses actually bit masking or recursion to form each subset, or recursion to form each subset. So we went with a bit masking actually. This is fine. The third one here, time complexity, overall time complexity would lead to because of 2 to the uh, 2 to the power of n into n, 2 to the power of n into n. The overall time complexity would lead to because of 2 to the power of n into n, since we check all the subsets and each element per subset. So that is also one thing. So this is the time complexity actually. Yep. So what will be the space complex, sorry, some of the use cases, what will be the use cases actually, so where we make use of it. So we make use of it within the actually power set actually. We use this one in the power set, one thing. We will be making use of it in the backtracking. So this is also one thing. And finally, we'll be making use of it on the combinatorial optimization problems, right? Combinatorial optimization problems. Yep. So these are some of the use cases of this one. What do we call? Subset enumeration algorithm. Yep. So I wanted to discuss these things with you guys actually. Yep. I wanted to discuss these things with you guys. So we are done with this algorithm. Next, we don't have anything to discuss. We don't have further algorithms. We are done with the whole algorithms playlist, right? So we have a number of playlists actually within the all algorithms playlist. So we are done with all the algorithms. So this is going to be the last algorithm that we'll be discussing, right? For the YouTube actually, right? So we have come to the end, and this is going to be the last algorithm, nothing but subset enumeration algorithm. And also I'll be uploading this particular this one, what do you call, this one, advanced or miscellaneous algorithm, this one, all these algorithms on my GitHub. You can just check the same. Yep. So this is also one of the thing I wanted to say. Yep. So we are done with this. We are done with all the algorithms. We'll be finishing this one today. We'll finish it off today actually. Um, so as we are done with the algorithms, all the algorithms, from tomorrow, we will be solving only the LLD problems. So we have solved around 23 LLD problems actually. 20, what, 23, I think. Mm, just give me a second here. We are doing, I mean, we are solving the LLD problems, this one. What do we call? Mm, Parallelly, right? So are done with actually 23 problems we have solved. So from tomorrow, let's solve around 3 problems every day, right? So we have time, we have more time. So let's solve 3 problems per day, LLD problems. So we don't have algorithms. We have solved, we have discussed all the algorithms. So we'll finish it off this one today by the subset enumeration. And we have also solved the 250, around 250 problems, this one. LeetCode problems as well. That also we are done with the solving LeetCode problems as well. We are not left with anything. So we are left with only one thing, that is solving the LLD problems, right? So from tomorrow, let's solve 3 LLD problems per day, right? So we can solve 3 LLD problems actually. That's not a big deal. Yep. So yep. For now, let me finish it off. The algorithms, all the algorithms with this particular algorithm. So for now, this is it. Thanks for watching, guys.